Hi, I'm John Freeman. Welcome to Microservices, a high-level introduction. There are many presentations covering the low-level details of implementing microservices, such as Docker, Spring Boot, Vertex, and Akka. This presentation is going to step back and look at the challenges, benefits, and organizational impacts of adopting microservices. This presentation is aimed at both technical and non-technical team members. I will be introducing some of the technical concepts involved, but I'm not going to dive into the low-level technical details. So what are microservices? There's no standard definition, but there are some common features of microservices. Microservices have a narrow purpose. Microservices are a way of splitting up an application into smaller applications, dealing with specific areas of functionality. Microservices are part of a larger system. If you just have a small application, you can call it a microservice, but the typical issues won't apply. Microservices have implementation isolation. The implementation of each microservice is hidden from others behind a clearly defined external API. This means separate source repositories, separate builds, separate databases, independent versioning, and independent releases. A microservice project consists of multiple teams working in parallel. Microservices should be developed independently, with the external API being the interface between teams. Microservices are an opinionated form of service-oriented architecture. Distinguishing features typically include hosting each service separately, dropping the enterprise container, and leveraging cloud infrastructure. This is a graph of Google searches for SOA and microservices since 2004. Popularity for SOA peaked in 2006. Since then it's fallen by about 75%. If you were a developer in 2006, you probably remember every company wanted to be able to say their product was built using SOA. The same thing is beginning to happen with microservices today. I suspect what this graph shows is for about 3/4 of the companies who tried SOA, the additional effort didn't provide sufficient benefit, and they mostly abandoned it. Since microservices are a form of SOA, let's assume the same is true and about 25% of the companies trying microservices will benefit. This presentation will help you to identify if your project is likely to benefit and to put you on the right path to achieving those benefits. Let's start by identifying some of the issues with large monolithic applications. It's difficult to scale the team. It's hard to keep pace with technology. They can be slow to build, deploy, and run. Typically involves long release cycles and large risky releases. And there can be a long onboarding time for developers. Let's look at the benefits of microservices. The most compelling reason to use microservices is you can achieve much greater total productivity on a large project by having parallel development teams. Multiple small teams can work on separate microservices without conflicting with each other or waiting for each other. Productivity scales almost linearly until you have the same number of teams as microservices in development. This allows for significantly shorter delivery timescales on large projects. Microservices are cloud-friendly. They provide fine-grained scalability, allow the use of cheaper VMs with lower resource requirements, and use design patterns that avoid the need for locking between nodes. Microservices allow for implementation diversity. This allows you to use the right tool for each job, keep pace with technology and best practice, and access a larger pool of developers to recruit from. With microservices, each new service is a clean start. New services are always an opportunity to update to the latest advances in technology, to refine your implementation of design patterns, and to iterate improvement. Each microservice is a manageable size. This means there's less to learn, less to update, less to rewrite, less to build, less to deploy, and less to run. They're never too big to refactor. Microservices allow you to focus on services that change. Even if only 10% of your microservices are using the latest technology and best practice, if these are the 10% that are under active development, you'll still have happy and well-motivated developers. If a service is working and not under development, there's no need to spend money updating it, other than applying security updates. Microservices encourage frequent, small, low-risk releases. You can even do canary releases during office hours with zero downtime. Let's look at the misconceptions about microservices. The first misconception is small equals simple. If we look at the programming model we have with a large monolithic application, we typically had a relational database with ACID transactional properties, and we called services using local method calls and exception handling. With microservices, we replace this with distributed transactions, eventual consistency, event sourcing, and reactive systems architecture. The difference between these two programming models is similar to the difference between paying with cash and paying by check. Imagine a world where the only form of payment is cash. I go to the supermarket, pick out the goods I want to buy, go to the till, hand over the cash for the goods, and leave with the goods. This transaction is effectively atomic because I only leave with the goods if I have successfully paid for them. If the transaction fails, I keep my money and leave the goods in the store. This transaction is immediately consistent because as soon as I pay the cashier for the goods, I have less cash in my possession. This transaction is isolated because I can't be in two places at once, paying two different cashiers. This transaction is durable because the cash and goods are physical items representing the state. An in-person transaction is also like a local method call in that it is very reliable and any problems, such as offering the wrong amount of cash, are easy to handle and resolve. Now imagine a world where the only form of payment is by check and you have to wait for the check to clear before you can take your goods. Obviously, I can't go into the supermarket and wait 3 to 5 days at the checkout for my check to clear, so the supermarket and I have to change the way we interact. So in this scenario, I go into the supermarket and place an order for the goods I want. I pay by check, and I tell them when to deliver the goods. My transaction is no longer atomic. It is now distributed across 3 separate services. On the day of my delivery, my check needs to have cleared, the goods need to be in stock, and there needs to be space in the delivery truck for my order. Any of these 3 things could fail. If they do fail, the supermarket may have to reallocate space on the truck, return goods to the shelves, refund my payment, and inform me of the failure. The balance in my bank account is eventually consistent. I may have different checks being paid in and paid out with no certainty when they will clear. I can check my balance and see how much money I have available to spend at that moment, but I've no way of calculating the amount of money I actually have. This is because I may not be aware of all the uncleared checks involved in my account. This may lead me to go overdrawn and may cause checks to bounce. A bank account balance works on the principle of event sourcing. Instead of storing the current balance of your account, it is calculated based on the transactions. These transactions are the events. This enables the notion of cleared and uncleared transactions, which are used to ensure sufficient funds are available for transactions to complete. This allows multiple transactions to occur simultaneously without requiring locking across all the bank accounts involved in the transaction. Shopping by placing an order could be implemented as a reactive system. For example, if your local supermarket was unable to fulfill an order, the order could be redirected to a nearby supermarket instead. So we have two quite different approaches: cash payments versus check payments. Hopefully it's clear that the cash approach is the simpler of the two. So why do checks exist? One reason is cash doesn't scale. It's not convenient to store and move large quantities of cash. The same concepts that make using check payments harder to implement also make microservices harder to implement. However, it's worth it for the same reason. Microservice projects scale better. The takeaway from this is microservices are more complex because we're replacing a programming model that was built out of reliable and predictable steps with a model where failure and uncertainty are expected at each step and where you have to write code to handle that. The second misconception with microservices is because they're small, they're less effort to write. Unfortunately, microservices are more effort to write. This is because you have to implement distributed transactions, eventual consistency, event sourcing, reactive systems architecture. There are more builds to set up and maintain. Code and data is duplicated between services. There are more external APIs to write. More time is spent versioning and releasing artifacts. And there are more servers to manage and support. The final misconception is it's another evolutionary change. Unfortunately, this is not the case. It's not like choosing between Java Enterprise Edition and the Spring Framework. It's going to affect everything you do. Your organizational structure will need to change. Various responsibilities will need to be devolved to the microservice teams. It will change the way you run projects. Your APIs will be different. You'll be using different design patterns, and it will change the way you test, release, and support software. Let's consider how microservices will affect your APIs. Your APIs will need to be idempotent. You need to make it safe to retry API calls because there are many more potential points of failure. Your APIs will need to use universally unique IDs. These will help you to implement idempotency and are generally required by NoSQL databases. Many of your APIs will need to use event sourcing. This is necessary when storing mutable data in eventually consistent databases. Your APIs may need to follow reactive systems architecture. This will help with performance and reliability. Many of your APIs will have to support distributed transactions, which are a largely unavoidable side effect of using microservices. Because your microservices are built using eventually consistent services, your APIs will have to be eventually consistent as well. Let's have a look at the infrastructure requirements for microservices. Microservices need a cloud platform. There are simply too many servers to maintain manually. Be careful when choosing a cloud provider. It's generally better to go with one of the large established providers than end up being a guinea pig for a new provider. Once you've written more than a couple of microservices, you will soon find you will need a container manager. There will simply be too many container instances to manage manually. Popular container managers include Docker Swarm and Kubernetes. You will need an identity and access management service. This will help you with users and passwords, provide access key management, and allow you to configure who has access to what. You will need an API gateway service. This will be the external entry point to your application. This will deny access based on your IAM service and will route external APIs to internal microservices. You will require a monitoring and log analytics service. With microservices, there are simply too many separate log files to inspect individually. This service will assist with implementing auto-scaling, implementing back pressure, implementing alerting, resolving partial transactions, providing status dashboards, providing performance analytics, and providing a support console. You will need a configuration service. With microservices, configuration is dynamic. Nodes may be added and removed at any time. It's best to have a central location to manage and to look up configuration. Reactive systems are asynchronous and message-based. Going back to the shopping by check analogy, there is no synchronous exchange of cash for goods. There is an order, which is the message from the customer, and there are goods that are delivered at a later time. These goods are the message from the supermarket. So when microservices are implemented as a reactive system, they need the equivalent of a delivery truck to deliver messages to the clients of those microservices. The notification service is that delivery truck. The notification service will typically deliver messages to clients using HTTP push, mobile push, or email. To deploy your microservices, you will require a deployment pipeline. Synchronized releases and release freezes are not practical for microservices. Small releases would be too frequent to do manually. You need a mechanism to ensure dependencies are satisfied before deployment. This pipeline is completely dependent on having excellent automated test coverage. You may want to consider feature flags as a way of quickly enabling or disabling new features. Microservices will involve difficult organizational changes. Before microservices, we were often working concurrently. This is where people and teams have to coordinate their work because it is affecting others. The overhead of concurrent development is relatively low within a small team. The overhead of coordinating work between teams is much higher. It slows down entire teams and causes havoc with planning. With microservices, you aim to work in parallel. This is where the work is separate and doesn't require coordination. Microservice projects should be run in such a way that concurrent work only occurs within individual microservice teams. Work between teams and other parties should occur in parallel. You should resolve all dependencies on other teams and other parties before assigning the microservice to a team for implementation. The easiest way to sabotage a microservice project is to undermine the ability of your teams to work in parallel. If your microservice project is going to be successful, there are some rules you will have to follow. Firstly, do not share code between microservices. There is a much higher concurrency cost than with a monolithic application. This is because changes are not atomic with multiple source repositories. It can take multiple teams to schedule and apply changes. The more microservices that share the source code, the more there are to update. Technical debt builds up on services that aren't kept up to date, and you can impact the release schedule across multiple teams. Finally, it may take a long time to get feedback and iterate improvements. Obviously, this doesn't apply to using third-party frameworks such as Spring Boot. Do not mandate specific frameworks, libraries, languages, and internal implementation patterns. If you try to impose a one-size-fits-all approach, you'll lose the productivity benefits of being able to vary the implementation approach depending on the requirements. If you try to impose consistent implementation choices across your microservices, one of two things will happen. You'll either be stuck with all your early mistakes because no one is permitted to change anything, or you'll be stuck with an exponentially growing cost of updating your old microservices every time a change is made. Given you should avoid transferring microservices between teams, there is little benefit in consistent implementation choices across teams anyway. Do not maintain a central design authority with approval over all design decisions. Central design authorities are important on large monolithic applications. It's worth spending the extra time to get a decision right first time, when a large team may be stuck with a decision for many years. With microservices, a single team should be responsible for a microservice for its entire lifetime. This includes design, implementation, support, and maintenance. You don't want an external entity imposing days or weeks of delays for decisions that are small in scope and easily changed. Instead, you want your microservice teams to feel ownership and responsibility for their services and to be able to use an agile, iterative approach to continually improve. Finally, do not run a microservice project like a large monolithic enterprise application project. This is a lot easier to say than to do. Everybody's first instinct is to stick with what we know was working before, to twist your microservice project into a familiar shape rather than adapting to its new shape. You really have to re-evaluate all your assumptions and procedures. Ask yourself the following questions. Can this responsibility be devolved to the microservice teams? Am I doing everything I can to minimize concurrency between microservice teams? What is the best option given my goal is to achieve maximum total productivity even at the cost of individual productivity? Given many people on the project lack previous experience with microservices, and it's a rapidly evolving field, how can I encourage research, knowledge sharing, and short iterative improvement cycles? Now some advice on how you should run a microservice project. Embrace diversity. You'll likely end up with a mix of teams. So you might have multiple Java teams because developer resources are easily available. You might have a Scala team to work on the most performance-critical services, a Node.js team for services specific to web front ends, and a Go team for simple services where lower resource requirements can deliver significant savings on hosting costs. You should communicate ideas and best practice. This encourages a level of consistency between teams without holding anyone up. You should have an API guild. This improves API consistency between services. It's important to get your external APIs correct the first time. API changes will not just mean rework for the team implementing the service, but disruption and rework for other teams building against the service as well. You should strictly follow test-driven development or behavior-driven development. High test coverage with well-written tests is essential for microservice projects. You need both integration tests and unit tests to ensure microservices work correctly together. As well as preventing defects from being released, it's important to catch defects before they disrupt other microservice teams. And you should run each team as if they are a separate company. Make teams responsible for design, implementation, and support. Track metrics for each team. Bill internal users for using microservices. If you get this right, you will empower your teams with the agility of a startup. Here are some factors to consider for when not to use microservices. If you're a small startup with tight resources, if the application is small and unlikely to grow, if you primarily need ACID behavior, if you have a lot of cross-service transactions. Here are some factors of when it is appropriate to use microservices. If you need to write a large application quickly, as long as you can resource multiple teams. If you're maintaining a large application for a long time, and if you need fine-grained scalability. In conclusion, microservices are a revolutionary change in approach. They are more effort to write, but productivity scales better. There is a large increase in skill set requirements. Do not underestimate the task of adopting microservices. While microservices are a bad idea for most small projects, they are definitely worth considering for most large projects. Thank you for listening, and watch out for my next video on microservice design patterns.